day, students. My name is T.A. Poppy. I'm a civil engineering lecturer at TVET colleges. Today we are going to look at construction planning level 2. We are going to look at topic number 3, which is based on the foundation. The outcomes that we are going to look at is as follows. We have to go and look at what is the foundation based on the structures that is going to be constructed. We are also going to look at the functions of the foundation. We will also check on the settlement and the different types of the settlement that the structure might incur. We'll also look at the types of the foundation, and we'll also have to go and look at what are the types of the soil that gives us problem during the construction, and why is it that we need to do the foundation before we can construct the structure. And lastly, we'll look at the site investigation processes and who is supposed to do it and why is it necessary for the site investigation to be done. Then to start off with, we have to know exactly what is the foundation. So the foundation basically is the base of the structure. So the beginning of all the building, there should be a foundation. And without having a foundation, the structure is not going to be strong, it's not going to last longer. So you must always make sure that the strongest element of the structure is going to be the foundation. So the functions of the foundation, if you look at the building there below, it has got some little bit of a crack to indicate that it was going to collapse, or it is collapsing, because the poor foundation which was constructed on it could not be able to withstand the load of this building material that has been used. Then the functions of the foundation is going to be to level the building, or to make sure that the structure that is going to be constructed is in a level surface, and also to be able to carry every material that the structure is going to be constructed out of. And lastly, just to tie the structure together, that the structure doesn't fall apart. So just make a little bit of an experiment here, because I know if I put most of the expensive equipment, you might think this thing is very much expensive. So I just took something that you can also be able to do at home. Just take 2 tins, and you have got the bricks, old bricks that you can just pick around the yard, and then you have got a little bit of sand that you just put on a container. So using these 3 or 4 materials, you can be able to identify or check whether if the foundation which is going to be strong, how are you going to identify that? So I've got number A and number B. On number A, I've got the other tin being placed facing upside, and on number B, I've got the other tin faced downwards. So the question will be, which one is going to be or pose a very strong foundation for the structure? If you look at it, most of the people might think this one is going to be strong enough because it has got a nice surface base on top, and this one is not going to be strong enough, which is the opposite. Because if I put a load on top, if I put a brick on top of this tin is going to sink down into that soil. That means this foundation is not going to be strong. But if I put a brick on top of this, then the base of this container or of this tin is going to be able to support the material which is going to be placed on top. So you can be able to do that experiment at your own time. There is this building which was constructed at Johannesburg Zoo. This building has been lasted for many years, and it has never ever had any cracks on that structure, because, and if you look at it, it wasn't constructed with any type of foundation. It was built on top of a rock. There is a rock surface underneath there, which this building was constructed on top without having any foundation. You can also relate that to the biblical story. So if you build the strong house, you have to build it on top of the rocks, but if you build it on the soil, that structure is going to collapse. Then why do we have to consider the types of the load now that needs to be carried by the structure? We have got 2 different types of load. The first load is going to be the life load, and then we have got the dead load. When we talk about the life load, A life load is each and every material which is going to be temporal on the structure. That will mean that material, if it's taken out of the structure can still be able to sustain its stability. Like for instance, if I can give an example of myself, if I want, I can put on the jacket. If I take out the jacket, there is nothing which is going to affect me because that is a life load. It's something that can be able to be taken out of the structure without any damages. But in terms of the construction, the rain, the wind, the storms, they don't remain on that. They come and disappear. When we talk about the dead load, it's the permanent structures now. That means if you take out that structure, that member being taken out of the building, the structure is now going to collapse or having some effect. So like for instance, if I can give you an example again about myself, if I said I don't want to use this left arm today because I can only use my right arm to ride, I cannot be able to leave this arm at home. So if I take this arm out, that means now the whole structure is going to be affected. So you've got the life load and the dead load. So the dead load in the structure is going to be the material being used to build the structure, the roof itself. All those materials cannot be taken out of the structure because it's going to affect the structure stability. Then in terms of the settlement, as we said, we're also going to look at the different types of the settlement. We have got your normal or your standard settlement, which is going to have all the building sinking down into the ground without any other part affected. So the whole of the building, when it sinks down to the ground, we said it has got a normal settlement. So in terms of the differential settlement, it's when one part of the building is sinking more compared to the other part of the building. When that happens, it might be resulted because maybe the type of soil on the ground where the building was constructed was not exactly the same. So if you have got that problem, that means where there is a weak soil, the soil is going to make lots of compaction and then it's going to result in a structure to collapse. Then in terms of the rate of the settlement and the time that the settlement takes place, mostly when you are, after you build your structure, the settlement rate is going to be too high. But as the years goes on, then it's going to curve and then it's going to be normal. Then that will mean it's no longer going to settle that much going down. Then it's going to reach its standard settlement. Then you can be able to see the examples. There is the normal settlement where the whole of this building is sinking down together uniformly. But if you check on this other side, the other part of the building is sinking more compared to the other one, which can be resulted because maybe the soil on this side was not strong enough compared to that one. It can have some different effects on the structure. So just to elaborate more on that, you can be able to see if you dig just to level the surface that you can build the structure and you go and compact the soil on that side, this soil is going to be compacted. The effect is that it's not going to be that much strong enough compared to the soil which is not disturbed on the ground. Then that whole part which is going to be compacted is going to start compacting itself, and then as you build on the material, the weight of the material is going to compact itself and then it's going to start to collapse. That is just like another indication. And the danger is if you have to bond the two structures, never put it on a same level or join the old structure with the new structure, because the old structure is already settled down, but the new structure is still coming in with its own settlement. Then they're going to result in a crack because this structure still have to go down to settle and the old one is already settled for its own settlement. Then you can be able to see now, even if the examiner can just give you a type of a structure like this and ask you what type of structure or settlement is it going to be. Hence you can be able to see slanting on one side. That means it's going to be your differential settlement. Then we have got the types of the foundation. So the types of the foundation is grouped or divided into two. So you have got the one which is the shallow foundation and you have got the deep foundation. The shallow foundation, it means it's a very light type of foundation. It's the foundation that you can be able to dig with hands. It's the foundation which is normally is going to be less than 1.5 meter. But once it exceeds 1.5 meter, where you will start now looking for the the excavation equipment, the bulldozers, just to come and dig the foundation. That will be considered to be a deep foundation. Then, in terms of the concrete foundation structures which is going to be done, number one, you must know what is an in situ concrete. You must also know what is the precast concrete. When we talk about the in situ concrete, it's when you mix the concrete on site and then you go and put it inside the trench and then you let it dry and take any form or any shape. But if we talk about the precast, that means that concrete is going to be manufactured somewhere in the factory and then you go and buy the end product and then you can just come and install it. So those types of the shallow foundation, as we have indicated, is the one that you can be able to cut or dig the ground using your own hands without any equipment. So there are 5 types of those shallow foundation. Number one is your strip foundation. Then you have got your raft foundation, you have got your pad foundation, then you have got your cantilever foundation, and lastly you have got your buoyed foundation. So I'll just show you exactly how do they look like in reality so that you can be able to relate when it comes into your exam. So this is the normal standard strip foundation. So your strip foundation is normally going to be the one that normally used in residential houses, which is going to be a 1-story residential houses. Somewhere, somehow they can put the reinforcement on it or not putting any reinforcement on it. Then you have got your pad foundation. Your pad foundation is only supporting the area where the column is going to be situated. So you don't have to put it along and make that strip like you saw it on the strip foundation. You only put the concrete where the column is going to be. Then after that, when you put all those columns where they are going to be, then you can lift it and elevate and put a ring foundation on top. Then you can start building up your houses. Then that will mean your house is not going to be seated on the surface ground, but you will see that when you talk about the pile foundation. Then you have got your raft foundation. A raft foundation, you will notice that when you are building the structure, wherever the wall is going to be constructed, the foundation will slide down to give more support. And this type of a raft foundation, it is the combination of the foundation support together with the floor slab. So everywhere where you are going to have a wall in between, you have to go and create that foundation and then pass on with the floor. So the floor and the foundation, they are in one uniform thing. There you can be able to see clearly that the wall is supposed to be supported on this side. Hence, we have already created that space for the foundation. Then you have got your slab going into this side. The way they form that is due to the fact that if you are building it, you must always put the DPM underneath and put the reinforcement. Then you come and pour the concrete. The concrete will go and sort itself inside the trench, and then make sure that when you are building, because you won't be able to know exactly where the foundation is, you must mark on the outside so that when you start building, the building is going to be exactly where the foundation is supposed to support. Because at the end, the whole of that structure is going to be covered and you won't be able to know where did you divide to put your rooms or the walls. Then your cantilever foundation, which is the one that is going to have only supported on one side and then it's got another hanging part on the other side. There you can be able to see an example. It is supported on this side, but the whole of that part is overhanging. The reason for that is that if you don't have strong material or strong soil or ground to be able to put the foundation, you can put it where you've got a strong ground, and then from there you can take it and extend it to have an overhang. Then you can be able to see a clear example where they put the whole of that building, and then underneath that building, they put or extend the overhang of that structure. Then in terms of the deep foundation, we have got only one. Remember on the shallow foundation, we did 5 of them, which was the strip, the pad, the cantilever, the buoyed foundation, and the raft foundation. So now on the deep foundation, we have got only one, which is the pile foundation. So for the pile foundation, normally it's going to be used for the very tall building. Then this is the equipment that they will use to dig for those pile foundation. They will use the rigger. If you haven't yet seen the rigger, maybe you might have seen this car moving around, which has got that part looks like a drill. It's the one that they normally use to drill on the ground to indicate the area where the pile is going to be placed. Then on the pile foundation, that will mean if they drill down into the rock and then they put this pile foundation, then they put the ring on top, the whole building is suspended from the ground. Even if you can take the soil around, this building is not going to be collapsing because the building is not built on top of the soil. The soil can be taken out, but the building is going to remain stable. Just to clarify on that, you will be able to see the whole of that building is elevated from the ground because it is not supported by the ground, but it's supported by the pile foundation. So even if the ground is not there, the problem would just be you won't be able to have any access into the building, but the building won't collapse. There you can be able to see the extension. Some of you might wonder, how do they have the top of the bridge going to the sea and stuff like that? And what type of foundation did they use? Why this thing is not collapsing? They also use that type of foundation, which is the pile foundation. Then the other type of foundation, which is, it doesn't matter whether if it's going to be on the shallow foundation or on the deep foundation, is what we refer to as the step foundation. So a step foundation, you'll only use that if you have got a place which is not flat or which is not level, but you wanted to build the structure on that area without leveling it, then you will be required to use a step foundation. Then you can be able to see the sample of a step foundation where the building was built on a slopey area. Then we also indicated that we are going to look at the types of the soil or the soil which is giving problem when you are building the structures. So those type of soil, they are classified into 4. We have got the sandy soil, we have got the clay soil, you have got the organic soil, and you have got the collapsing soil. So let's just look at that in 1-1. So the sand soil, its problem is that the sand soil doesn't bond together clearly. And when it's too dusty, then, or when it's too wet, it's going to absorb more water. And then when it talks about the clay soil, it has got a little bit of a challenge. When it gets water, it absorbs water and then it expands. But when the water is dried out, then it shrinks and then it goes to leave those cracks. Then in terms of the organic soil, in your organic soil, the organic soil will be having some of the trees, the leaves inside. So when you put the structure on top, those leaves and the tree cannot be able to support that structure. Then it's going to start compacting itself going down. So when that happens, just know that you mustn't use that type of soil. Then you have got your collapsing soil. The collapsing soil is the very strong soil, but only when it dries. But when it starts to absorb more water, then it's losing the strength and then it just go and collapse. Then it erodes. Then just to wrap it off, you have got the properties of those type of soil. Hence you have indicated you have got the sandy soil, which is now powder, and then it loses poorly, and then we say the clay, it's a little bit slippery and then it expands, but it causes the crack. We have got the organic soil, which has got plant materials, whatever that is going to be within that soil, and then it's very much weak in terms of carrying the structure. Then we say the collapsing soil is going to be able to, it needs to be tested by the geotechnical engineer so that you can check whether if it's strong or not, but when it absorbs water, it's going to be weak. Then the last thing that we said we are going to look at is the site investigation. So in terms of the site investigation, the person who is going to do the site investigation is called the geotechnical engineer. So a geotechnical engineer, that is the person who works with a piece of land. So that person will determine what type of foundation needs to be used on that structure. And then he will be using this instrument, which is called a DCP, and then which is the dynamic cone penetrometer. So just look at that piece of land there. You might wonder whether if that type of soil, is it a collapsing soil? Does it have any material on it? Is it clay? But if a geotechnical engineer comes in with his instrument, he can be able to tell or determine how strong is this soil, how weak is this soil, and then they can also tell you exactly which type of foundation needs to be used. You might wonder how the DCP or how does that instrument look like. So that is the set of your DCP or the dynamic cone penetrometer that you can be able to use. How to use it, you just drop the weight, and then when you drop the weight, how far it is going to go down into the ground. That measurement will tell you how strong it is, and then you go and record that measurement, and then you can test whether if it can be able to carry how much load, whether if you have to build the double story, the single story, it will be determined by that type of the testing. Then the cause of the building to collapse, if you have got a wrong building foundation, or if you didn't compact fully in your foundation, the building can collapse. Then you must have also these two methods, which is used to prevent the absorption or to prevent the absorption of the moisture on the structure. It can either be by means of the DPC or the DPM. So the DPM is that membrane that is laid under the structure so that the water which is coming below cannot be able to penetrate and get into the structure. Then for the DPC, it's only placed on the part of a brick just to prevent the water from penetrating into the superstructure. Then in terms of the long walls, if you have got the DPC, you will have noticed that the DPC automatically separate the two structures because there cannot be any bond. So you can take the whole of that structure away because it's not bonded with the below structure based on that part of the plastic. So in terms of the long wall can be able to collapse at any time because it's not supported from the foundation. So that is why you have to make a bridge in between so that the length of the wall can still sustain the strength. Okay, then you can be able to see now on the tall building that they have used the pile foundation. And when you are working with the foundation, automatically you are going to use the cement. So avoid contact with the cement because the cement, it has got this disease which is called the cement burns. The cement burns is when you are getting into contact or close contact with a cement. So always make sure that you protect yourself from contacting the cement because that damage is very much severe. And then this, I just took it from one of the articles where they indicated that the injury can also sustain even for 8 years without having any part of healing that. Then lastly, you must also check that if there is any problem on the foundation, you can never ever be able to fix the structure. So this part of the building, people normally used to say they can come and close your crack. There is no way that you can close the crack on the structure. If you want to close the crack, it means putting material inside that crack, and once you put the material, you are opening up the crack. So when they say they're closing, they're just increasing the crack. Remove that and then go and sort out the issue of your foundation. We don't want you to go around and see the structures being demolished because of the failure of the engineers, because that sustains a lot of problem. And building, it can take a long time, but demolishing, 3 seconds will be enough to demolish that. So if you are not strong enough, you can be able to kill people when you are building a structure. Remember, or look at the building of the structure without the structure being completed, and then the whole of that material. It's a waste of material. The people are injured, some are fatal. So you must always avoid making risk with the structure, because it is true that the tenants have got all the trust in you as the engineers. And if you are not being trusted, how do you think people are going to trust the structure that you are going to construct? So at this stage, we have already covered the part of your foundation. You know now what is the foundation, why is it important for us to build the foundation, and which type of foundation can be used in a different version after the geotechnical engineer has already surveyed the site to check what type can be able to be used. And you also know exactly how can you make sure that the building is strong by compacting into the soil. And remember, these outcomes, it is made for you. If it is designed for you to be able to do it, just know that somebody has already done it before to tell that it can be done. And if that is the case, you can also do it. Okay, student, for any information on a social media interact, you can contact the number that appears on the screen. Thank you.